In this example, we're going to use the root test to determine whether or not a series converges. So in this one we have the series from 1 to infinity of n to the 10th over negative 10 to the n plus 1. We're determining whether or not it's absolutely convergent, conditionally convergent, or divergent. Now, pardon me, there are lots of ways that you could perhaps attack this problem to see whether or not it converges or diverges. In this case, we'll use the root test. In particular, one of the things that might tell us that we want to use the root test is that we've got single terms here raised to a power, which means it's a little bit easier to simplify with a root test. If we had multiple terms in the numerator or in the denominator, that probably wouldn't be a good choice to use the root test, because there wouldn't be ways to distribute the root over the multiple terms. All right, so let's use the root test. Remember, the root test gives us absolute convergence or divergence, just like the ratio test does, so we don't need to worry about conditional convergence here, even though the series is alternating, as long as we're able to apply the root test, I should say. All right, so for the root test, we'll take the limit of the absolute value of the terms raised to the 1 over n power. Well, the absolute value will make this negative positive, is the only effect it'll have, and then we can put the 1 over n power distributed over the top and the bottom here. So we'll get n to the 10 over n on top. When we take that 1 over n times the n plus 1, we'll get a 1 plus 1 over n for the exponent on the 10. All right, to see how this is going to work for a limit, notice that I can rewrite this as n to the 1 over n raised to the 10th power. And on top, we can break the sum up as a product. We have 10 to the first times 10 to the 1 over n. All right, so as n goes to infinity, certainly 1 over n goes to 0, so 10 to the 1 over n will go to 1. On top, n to the 1 over n is one of those special limits, and it goes to 1. You can use L'Hopital's rule by, of course, taking log of it and going through that whole process. But in particular, this is one of those that you should recognize that the limit as n goes to infinity of n to the 1 over n is 1. So we get 1 to the 10th on top. That all simplifies to 1/10, which is certainly less than 1. So since the limit turned out to be less than 1, we can conclude that the original series is absolutely convergent by the root test.